this MB is the carryover moment. Here you can see that here MB is the carryover moment. Now, as we have derived this, MB is equal to MA by 2. So here this MB is nothing but MB is equal to this is MA by 2, and this is called as carryover moment. Okay, and this half is nothing but the carryover factor which is transferred here. This carryover factor and this is carryover moment. Now I can say that this end, I can call this end as a nearer end. This is nearer end, and this end is, I can call this end as a far end. Okay, so far end. Now, so if you applied a moment MA at the nearer end or at any end, if the far and at the far end the moment generated is MA by 2. So now further, here after this carryover moment, the next point is stiffness. The next point is the stiffness factor. Stiffness, we denote this by letter K. As we know that P, load, is equal to, says K into delta, where P is equal to load and delta is equal to what we can say deflection, and this K is nothing but what we can say stiffness. These basic things we know this. Okay, in the case of moments, we can say that M is equal to K into theta. So for M, the displacement is rotational. For the load, the displacement is either vertical or horizontal. For moment, theta will be there, either it is clockwise or anti-clockwise. So in this case, we also say that this K is the stiffness. M is nothing but instead of load, now I can say M is equal to what? Moment. And here deflection, now theta. This I can say that angular displacement. Okay, angular displacement, or simply I can say that this is rotation. This is rotation. It may be clockwise, it may be anti-clockwise. So now on this basis, now we will derive what is the value of this MA moment. Okay, what value of MA should be applied over here to get the unit angular displacement? That we will find out. Why we want to calculate that? Because ultimately we want to calculate the stiffness. Now if you look at this equation, M is equal to K into delta, I can modify this. K is equal to M into, instead of now for M, theta is there, theta. Okay. Now somehow if I make this theta is equal to 1, that is theta is unity, then I will get K is equal to M. So whatever may be the value of this M, it is the same value is of that stiffness, and now we are interested in the stiffness. So now this is the basic. So now after this, now we will go for this stiffness. Now again consider the same thing. Okay, so again consider the same thing. Now consider a beam. Okay, so again now consider this beam. I will go to the next page. Now consider the beam again. So here the hinge support is provided, and now here the fixed support is provided. Okay, as usual, this is our point B. Here it is the point A. Now if I again draw the deflected shape of the beam, so due to the application of the moment, so if I apply a moment M1, or let us say MA, the applied moment here is MA. So now due to this moment, the beam will be rotated in this way. This is the elastic curve. Okay, this is called as elastic curve. Elastic curve. This is called as